This is the Edexcel Ial Mathematics June 2022 Pure Math 1, P1. This lesson will be question 8, circular measure, dealing with circular measure in radians. Okay. Quite a lot of information is given here. So this is figure 3 on the right. That's a fan. So this is a fan. Consists of 3 identical sections congruent to the, so every way equals to O, A, B, C, D, O. So this is this whole thing. If you look at O is here, O, A, B, O, A, B, C, D, O. It's got 3 sections that look like that, right? Okay, OABO. So OABO is a sector of the circle with center O, and it has a radius of 9 centimeters. We make this a little bit bigger. Okay, so let's do it like that. So we have a radius of 9 centimeters over here is 9, and that's 9. Then the next piece of information that's given is O, B, C, D, O. O, B, C, D, O. There's another sector of the circle, a chunk of the circle, with the center O, and it has a radius of 84. So this whole thing has a radius of 84. Okay, this whole thing is 84. Both sides. Okay. Then another piece of information is given. Let's take a different color, green. AOD is the angle is equal to pi over 3 radians. So put your calculator in radian mode. AOD. AOD. So from A, O to D. Okay, that angle. Let's do it like this. This angle is pi over 2 pi over 3 radians. Okay. You don't remember how to do radian mode, so to put you press shift, and then you press setup, just above a blank button. And then mine, it comes as number 4, which is rad. Okay, press equals. So this gives you radian mode. It's given that AB is 15 centimeters. AB. So from A to B over here is 15 centimeters. Okay. Show that the length of arc CD is this. So we want CD. We want the arc length CD. Right, so arc lengths, just grab this thing. Take a look at this little diagram. So arc length is depicted by the S, and our arc length is equal to the radius times theta. So if this was our arc length here, it's the radius times the angle between the 2 radii. Okay. So let's go. Number A. To make this easier for myself, I'm going to let the angle BOA equal x. Okay, so just write that into my proof. So let the angle BOA equals x. Okay. Then we know that angle, we know what angle DOA is. Angle DOA is already given. So we have, let's just do green. So DOA was given as 2 pi over 3 radians. It's green in the, and if we take DOA and we minus our x from it, so our x is over here, running out of colors, make it yellow. So that's our angle x. So if we take DOA, oh, that's not very yellow, is it? And we minus this angle from it, we'll be left over with the angle we want for, in order for our proof to work, which is here. We want only this. Okay. So DOA minus our x is going to be equal to angle DOC. And DOC, remember x was BOA. DOC is the angle we need in order to use our arc length rule. Okay. So the question becomes, what is this x? What is this x angle? Because we need this angle in order to figure out what we must minus from DOA. So what is x? Well, if we take a look at x, draw it a little bigger. There's our angle x. And we know that these radii are 9. And we know that BA is 15 centimeters. Okay. That's also in centimeters. So if we take this arc length formula and reverse it, so if S is equal to R theta, then theta is equal to S over R. Divide both sides by R. Theta is going to be equal to S over R. And if we have S over R, then which is our, it's our length S over the radius. Well, our length is going to be 15 over the radius, which is 9. Okay. 15 over 9, which simplifies to divide both sides by top and bottom by 3, get 5 over 3. Okay. So now we have more information that we can use. So we had that DOA minus x. This is all our x. Okay. So DOA minus x must be DOC. So our DOC is going to be DOA, which is 2 pi over 3 minus our x, which is 5 over 3. Fantastic. Both over 3, so 2 pi minus 5 over 3. Let's leave that like that for now. So we know what DOC is. Just quickly remember why we're getting DOC. We're getting DOC in order to have the correct angle between the two radii in order to find the DC. Okay. So again, we use our S equals R theta. So we have S equal to R theta. And now our theta, our radius is 84. So that's from here. And our theta was what we just got, was DOC. DOC. Okay. So we can just do that S is equal to 84, is the radius, times by DOC, which is 84 times by 2 pi minus 5 over 3. Remember to put your calculator into radian mode. If you haven't already done it 100 times. All right, so this comes to, for me, 34.929. And we round to 1 decimal point. So 35.9 centimeters. It's a length. Okay. That's question A. Some more information is given. So the face of the fan is modeled to be a flat surface. So that just means 2D. And find, according to this model, the perimeter of the face of the fan, given your answer to the nearest centimeters. Okay, so it wants the perimeter of the face of the fan. The face of so the fan is this whole thing. This is our fan. Okay. This is our fan. And for perimeter, well, you have to do all of these lines mix. So there's lots of symmetry. There's this 1, 2, 3, 4, 5. There's 6 of those, and then 1 of these, 2, 3 of these. What else is there? There's those little round bits. Yeah, 1, 2, 3 of those, and you plus it all together. That's for perimeter. So we're getting perimeter of this. Oh, that didn't work. Let's just go. Okay. It's like a double fan. Let's move that out of the way. So for number B, our perimeter equals to, basically, we're going to have 3 of those curvy lines that look like this, plus 6 of the straight lines, 6 of the straight lines. And then there's 3 on the edge lines, these ones, 3 of those. So 3 slightly bigger curvy lines. Okay. That's what we're getting. So we have the perimeter. So 3, the small curvy lines was given as 15 centimeters. So 15 centimeters for these things. 1, 2, 3 are 15 centimeters. The big lines of 6 was 84 minus 9, because there's 84 is the whole thing minus the 9 of that bit. 84 minus 9 comes to, let's just write it in here, 384 minus 9. And then, oh, excuse me, I think there were 6 of those. There's 6 of these ones. And 3 of the outside lines, which we got from the previous question, which was 35.9. Okay. So 3 times 15, 84 minus 9, 75. Let's check if that works out. And that's going to be our perimeter. Put it all in the calculator. Perimeter equals 602.7, but it's asked for the nearest centimeter. So 603, rounded up. So perimeter, that answers question B. Number C, last part of the question. Wants the surface area of the face of the fan. Okay. And give your answer this time to 3 significant figures. Well, to do surface area, we just need, we're going to have 3 of these, 3 Okay, and then we're going to have 3 of these. Now we do the area of the segment is half times r squared. Right, excuse me, let me write that down. So area is going to equal a half times the radius squared times the angle that you use, theta. So you're doing that twice. So you're basically going to have area equal to 3 of the blue ones, small ones, plus 3 of the big ones. Okay. Let's work that out. We do the small ones first. So if we look at make a bigger version over here. The small one has a radius of 9 and it has an angle of 2 pi over 3. Trying to understand my own drawing here. I think the angle between these is actually it's x. So the angle here was x. And we just go back and grab what our x was. It's on the left here somewhere. Lots of working. Okay, x, 5 over 3. X over there ended up being 5 over 3 from the previous question. Good. So x equals to 5 over 3. So first area, we have 3 lots of a half times by r squared, which is 9 squared, times by 5 over 3. And we're adding that to another 3 lots of the long purple ones here, 3 lots of these. And that was 84 was our length, and our theta in this case was this one here. So the theta, the angle was 2 pi minus 5 over 3 from our previous question as well. 3 times r squared, 84 squared, times, oh, wait, let's do it this way. A half times 84 squared times 2 pi minus 5 over 3. Fantastic. Okay. All of this in the calculator. We end up with 4729.577 and so on. Right. It asks for 3 significant figures, which would be in the centimeters. So we have 4730 rounded, and the 3 significant figures are there. So 473 centimeters is the area of our flat fan in 2D, so centimeters squared. And that was question 3. No, C. Question 8, number C. All looks good. Fantastic.